This question is median of a rows wise sorted matrix. So you're given a 2D array, and then you're going to calculate the median in the matrix. So you must solve the problem in less than all of m times n. One way of saying this is because you can actually, add all of the num into the list of integer, the collection, and then doing the sort and then finding the median, the middle one, right? So in order to avoid this, you need to use a binary search. But again, let's start with the basics one. So for every single array, single row array is ascending order, and it doesn't mean the first value in the third array will be greater than any of these two previously. No, right? Like any of these can be a new star sorting array, right? So the easiest solution is this. So you create a list of integer, and I'm going to traverse the whole entire grid. And then I'm just adding the value into the list of integer, and then now this can be, so now this can be, using the sorting method. So I would say result sort collections sort results. So once I have this, I just basically like get the middle value, right? So result I get result of size divided by 2. So this will help you to get a middle value, and the middle value is a medium one for sure. So yeah, so this is a worst solution, but again, doesn't matter. So time and space is going to be all of m times n for sure. You can you add every single one of them, right? And then time, this is all of m times n, and then this is going to be the worst one. It's going to be so this will be like all of log mm, because you're adding every single one of these into the list, right? So this will be all of m, something like this. All right, so this will be the whole entire time and space. All right, so now let's do a little bit thinking. How do you do using binary search? So every single array is sorted, so that's going to be pretty helpful. And I definitely know the median index is definitely at the middle. Like it doesn't matter like your your array is like 1 to how much? 1 to e6, and this is 1 to e6, right? So it's from 1 to e6. It doesn't matter this is going to be like x. Like it does not matter. You can actually find out a way to cut off your binary tree. Binary search into half, very efficient. And then once you're going to cut off, you're going to traverse the whole entire array again to find out your another assumption mid, and then you just cut it down, and all the way to I and j will cross over, right? So I feel like it would be easier for me to actually dive into a solution. So this will be the binary search solution. I'm going to find out the total. So total number for this, the whole entire, the number of value in the grid is going to be grid.length times grid.0.length. And then how am I going to get the actual median? Since if you notice that the base index is actually 1, so what you need to do is actual median median is actually equal to total plus 1 divided by 2. One of the reasons why you plus 1 not only because the base index 1 is also, think about like 5, so your whole entire array is 5. Let me do this. So this is 5, right? So 5, if you don't have +1, just imagine if you don't have +1, 5 divided by 2 is 2. However, you should have 3. Okay, so because the base index, it was supposed to 0 to 4. I mean 0 to 4, yeah. And now you want to make your base index to 1 to 5, right? Something like this. And yeah, I don't know. There may be a lot of reasons. So, and I also want to know my mean and max. So mean will be initialized to max value first, and max will initialize to mean value first. So by the time I traverse the grid again, I will update my mean, mean comma 0. So the first index in the row is always the smallest, and max is going to be the same thing. So max and row dot length -1. So I just have to traverse mean less than max, and my middle value is always an assumption based on the mean and max. So max minus mean divided by 2, and I also want to know the count starting from 0. So once we are trying to do the binary search, right, in this question, in this type of question, what we need to do is, in this 2D array, if I give an assumption mid into this 2D array, how many value is actually less than or equal to this mid, right? Based on this count. So if the count is less than the actual median, so count is based on the assumption median, right? And I have the actual median. This is because if my mean is too low, so I'll have that my mean equal to mean +1, else max is equal to mean, and in this one returning mean. So I'm actually put my faith in count, and my count is going to be for in row 3 count plus equal count less equal the mid. So this might be easier for you to understand. I add every single one of them in the row when is less than equal. Okay, so private int count less equal, and I start with my ij from 0 to row dot length, and I will do the while loop, and I will do the k will be I plus j minus I divided by 2, and also I want to make sure if row k is less than mid. If this is happening, I'm say I equal k plus 1, else j equal to k. Alright, so this is less than equal, right? So normally we will write like this, but what this is doing is actually the upper bound. So upper bound is that you want to make sure the equal sign is always included for the comparison. This is because just imagine like this. If you want to set 2 right here, but this 2 is not actually the median, this 2 is actually the median. So even though those two are the same, you still want to move your pointer to k plus 1 if this is equal. So the actual median will tell you the actual spot. But if you don't have this equal sign, you actually stop immediately, and you never come across to this position. because I'm also returning the I over here. So this is why you need it. And okay, yeah, so this will be pretty straightforward. I feel like I still need time to understand the logic behind the whole thing for binary search. But let's talk about the time and space. Space list will be a constant. Time, this will be all of n, right? And this is going to be the between min and max, and it's going to be based on the log max minus min. I don't know, but it's actually less than m times n. So this is going to be a log. I would say log n just in case. And this is going to be the log of all of n. Based on all of n, this is going to be all of log r, something like this. So for the worst one, I actually don't know. So this is n times log r at least, but I don't know how do I include in this. Like this is actually based on the min and max in the array. 1 to 10 to the power of 6. So this can be very large, but again, it doesn't matter. The if the test case pass, this is how it is. Alright, thank you. Peace out.